Today, we're tackling something that might seem a bit mundane at first glance.
Oh, do tell. I love a good challenge.
We're talking about valves.
Valves, huh? Interesting.
Yeah, you requested we get into the different types and how they're used, especially in oil and gas.
It's a critical component in so many systems, often overlooked, but absolutely essential.
Exactly. And honestly, even I was surprised by how fascinating it all turned out to be.
I'm intrigued already. Where are we starting?
Our guide today is a fantastic YouTube video from SoNu's SiNgH Refinery.
Ah, yes. I've seen some of their work. Great for visual learners.
Right. Seeing those mechanisms in action really makes a difference.
Absolutely. It's one thing to hear about how a valve works, but seeing it, game changer.
The video kicks off with a pretty straightforward definition. A valve is a mechanical device used to isolate, regulate, and control the flow of liquids, gases, or slurries.
Makes sense. But it makes you think, why is controlling flow so important?
Yeah, it's something we take for granted, like turning on a faucet. We don't think about the mechanics behind it.
Exactly. But those mechanics are everywhere. Faucets, shower heads, car engines. Controlling flow is how everything works properly.
And when you scale that up to industrial processes, especially in oil and gas,
The stakes get a lot higher.
the video really hammered home the importance of gate valves. They call them isolation valves. And apparently they're the most widely used across almost every industry.
Isolation. Now, that's a powerful word in those settings.
Why is that? What makes isolation so critical?
Well, think about a pipeline carrying flammable material. You absolutely need to be able to completely shut off the flow.
For maintenance or repairs?
Yes.
Yeah.
And to prevent accidents. Isolation means you can stop everything in its tracks. That's crucial for safety.
Especially in oil and gas. The YouTuber actually shares this funny story about a job interview where he was asked to prove a valve was a non-return valve just by looking at it.
I love those kinds of tests. Really makes you think on your feet.
So why are these NRVs so important? Besides being good interview fodder, I mean.
Well, they prevent backflow, which could contaminate a system or cause dangerous pressure buildup. And as the story highlights, one of the key clues is that they don't have handles.
Uh-huh. That's how he knew. It's amazing how those little details can have huge implications.
It's all about observation and understanding the nuances.
What I loved about this video is how visually driven it is. It really encourages you to look closely at the different figures to understand how each valve operates.
Oh, absolutely. It's like a puzzle. You're trying to figure out how the design relates to the function.
Okay, so let's try to put those visuals into words. First up,
Oh,
the Julobe VLAV.
named for its shape, right? Kind of like a globe.
Exactly. And the video describes its main function as regulating flow.
It's like a dimmer switch for liquids or gases. You can fine-tune the flow rate with a globe valve.
Ooh, I like that analogy. Okay, what about the ball VLV? The video shows this ball with a hole drilled through it.
Pretty straightforward design. Either the hole is lined up for flow or it's not. On or off.
Seems pretty simple. Where would you typically find a ball valve?
They're common in lower pressure systems because they're so reliable. Think about those pipelines carrying natural gas across the country.
Wow, that's a lot of responsibility for a simple ball.
They need to be able to shut off that flow quickly in case of a leak. Could prevent a major disaster.
That's intense. Okay, last one for now, at least visually speaking. The butterfly VLAV. This one looks totally different.
It operates with just a quarter turn. Super efficient.
And the video mentions it's ideal for tight spaces. What kind of places are we talking about?
Think underwater pipelines, maybe even spacecraft. Anywhere space is limited, but flow control is still essential.
Wow, that's incredible. So we've got these different valves, each suited for specific applications. It really shows how much thought goes into these seemingly simple devices.
Definitely. Form follows function.
Now, this is where things got a little tricky for me. Control valves. The video mentions they can be added to other valve types.
Ah, yes. Adding a layer of complexity.
I was a bit confused. What does that actually mean?
Think of it like this. You take a standard globe valve, for example,
Okay, got it. A regular globe valve.
and you add a sensor to it. That sensor is constantly monitoring the flow rate.
I see where this is going. It's getting smart.
Exactly. Now, connect that sensor to an actuator. The actuator can adjust the valve opening based on what the sensor is telling it.
So it's automating the flow control.
Precisely. That's what a control valve does. It takes a basic valve and adds a layer of automation on top.
Okay, that makes more sense. But what's the point of all that automation? Where does it really come into play?
Control valves become essential when you need to fine-tune complex processes.
Like in oil and gas
Yeah.
or chemical manufacturing.
Exactly. Think of a refinery where you need to precisely regulate the flow of different chemicals, sometimes at very specific temperatures and pressures.
So those control valves are kind of like the brains of the operation.
A good way to put it. They ensure everything runs smoothly and safely.
Safety is key. And speaking of safety, the video highlights another important type: PSV and PRV valves.
Pressure safety valves and pressure relief valves. Critical for preventing disasters.
I've heard of those, but to be honest, I don't really know what they do. The names kind of give it away.
They protect equipment and pipelines from overpressure.
Which can be really dangerous, right? Especially with flammable materials.
Absolutely. If the pressure gets too high, these valves automatically open to release it.
So they're like emergency release valves, preventing explosions and damage.
Exactly. Remember the YouTuber talking about explosions? Well, these valves are a big reason why those explosions don't happen more often.
It's good to know. So we've got all these different valves, each with a specific role to play.
It's like an orchestra.
An orchestra.
Yeah. Each valve contributes to the overall harmony of the system.
I like that. We've got gate valves isolating sections, globe valves fine-tuning the flow.
Ball valves acting like quick on-off switches. Butterfly valves working in those tight spaces.
Control valves adding that automation layer. And then these pressure safety valves, like guardians, ready to jump in and prevent a catastrophe.
A perfect analogy. Each one is essential, working together to keep everything running smoothly and safely.
It's amazing how these seemingly simple devices can have such a huge impact.
It really is. And you know, at the end of the video, the YouTuber mentions that there are even more specialized valves out there.
More. So all of this is just the tip of the iceberg.
In a way, yes. Which leads to a fascinating question. How far can valve technology actually go?
That's a good question. What are the boundaries here?
Well, as technology advances, so do the valves that control it. We're already seeing valves designed for extreme temperatures, highly corrosive materials, even ones that can handle radioactive substances.
Radioactive substances. That's next level stuff.
Think about nuclear power plants or research facilities working with those materials. Controlling those flows safely and precisely is critical.
It sounds like this goes way beyond plumbing. It's pushing the boundaries of what's possible.
Exactly. And it's constantly evolving. The basic principles of valve technology haven't changed that much. It's still about controlling flow. But the way we achieve that control, the materials, the precision, the automation, that's what's getting really interesting.
We talked about control valves and automation earlier, but with AI and machine learning taking off, do you think valves will become even more intelligent, more self-regulating?
You're thinking ahead. And yes, it's already happening. We're seeing smart valves being developed that can monitor their own performance, even predict potential failures.
Whoa. So they can adjust themselves based on real-time data.
Exactly. It's like taking those control valves and giving them an even higher level of intelligence.
So it's not just controlling flow anymore. It's understanding it, predicting how it might change, and adapting accordingly. That's mind-blowing.
It is. Think about a pipeline network that automatically optimizes flow rates based on demand, weather conditions, even potential risks detected by sensors. It's not just reactive, it's proactive.
That sounds like something straight out of a sci-fi movie. But all this intelligence, all this automation, are there downsides? What are the risks?
You're right to ask that. With any technology, we need to consider the potential downsides.
Like what could happen if a valve malfunctions or gets hacked?
Exactly. As valves become more autonomous, we need to ensure they're reliable and secure. We don't want a rogue valve causing a major incident.
Right, because that could be disastrous. So it's a balancing act, right? Innovation versus responsibility.
Absolutely. And as engineers, it's our duty to consider these things carefully.
That's why I love these deep dives. It's not just about the facts, it's about the bigger picture, the potential impact of this stuff.
Right.
Even the ethics.
I agree. It's all connected. And speaking of the bigger picture, we've explored all these valve types. But there's one thing we haven't talked about yet that's especially relevant to oil and gas.
Oh, and what's that?
Flow coefficients.
Flow coefficients. I'm not familiar with that term.
It's a way to measure how efficiently a valve lets fluid pass through it, kind of like its capacity.
So in oil and gas, where you're dealing with massive volumes of liquids,
Understanding those coefficients is essential.
it makes sense. It's not just about whether the valve is open or closed. It's about how much can flow through at a given time.
Right, and different valve types have different flow characteristics.
So a ball valve might handle more volume than a globe valve, for example.
Exactly. Those nuances can make a big difference in system performance.
It's fascinating how these seemingly small details can have such huge implications for these large-scale systems, like a chain reaction.
That's engineering for you. It's about understanding how all the individual pieces come together.
And in this case, those pieces are keeping the world running. Literally.
Well said.
We've covered a lot of ground in this deep dive. Basic valve types, AI-powered smart valves, those flow coefficients. But I feel like we've only just scratched the surface.
There's always more to learn.
What excites you about the future of valve technology? What trends and breakthroughs are you watching?
What excites me is the intersection of the old and the new. You know, traditional mechanics meeting cutting-edge technology.
I like where you're going with this.
We're seeing the rise of 3D printed valves.
Oh yeah, 3D printing, it's changing everything.
Imagine creating a valve with these intricate internal geometries, customized for a very specific application.
It's like bespoke tailoring for valves.
Exactly. And it's not just about the physical design either. We talked about AI earlier. Well, AI has the potential to completely transform how we manage and interact with valves.
In what way? Give me an example.
Imagine predictive maintenance systems.
So they can anticipate problems before they happen.
Yes. Or self-optimizing networks that constantly adjust those flow parameters based on real-time conditions.
Okay, so we're talking about going beyond just basic automation.
Absolutely. This is about a level of intelligence that could revolutionize efficiency and safety across so many industries.
Pipelines that can basically think for themselves, that's a bit unsettling, to be honest.
It is a big shift. And as with any powerful technology, we need to approach it responsibly.
Right. All this potential, but we have to think about the consequences too.
Exactly. Make sure these systems benefit humanity and the environment.
That's the key, isn't it? We can't just get caught up in the excitement of innovation and forget about the bigger picture.
I completely agree. It's about using technology for good.
Well, I have to say, this deep dive has been eye-opening. Came in thinking about plumbing, but we went so much deeper.
It's a rabbit hole for sure.
We talked about the history, all those different valve types, AI, 3D printing, even ethics. It's incredible how much there is to learn about something as seemingly simple as a valve.
And we've only just scratched the surface.
You said at the beginning what excites you about the future of valve technology. Now I'm curious. What questions are you left with?
Good question. One thing that keeps me up at night is the challenge of designing valves for extreme environments.
Extreme environments.
Think deep space, the ocean floor, new energy sources that push the limits of temperature and pressure.
We need valves that can survive in those places.
Exactly. It's a constant challenge, finding solutions that are both robust and reliable.
It's like we're constantly pushing the boundaries of what's possible. Amazing.
And that's what makes this field so exciting. There's always a new challenge, a new frontier to explore.
Well, for our listeners out there, we hope this deep dive has sparked your curiosity.
There is a whole world of valves out there.
Next time you encounter one, take a moment to think about the engineering behind it, the role it plays in our modern world.
And remember, there's always more to discover. Keep exploring, keep questioning.
That's a great note to end on. Thanks for joining us on another deep dive.
It's been a pleasure.
Until next time, keep exploring and stay curious.